And so the first is Omah Williams-Duncan, an overview of phase 3 research about the exploration of the moon and asteroids by secondary students, EXMASS program.
So good morning. Thank you for being here. This research presentation that we're going to share today, Dr. Buxner already gave the title. So thank you again. So during our brief time together, we are going to share who we are, along with background information about our research, of course, the purpose, the research questions, the methodology, some preliminary findings of our phase 3 research. And then please keep in mind that this presentation is followed by a second presentation that's going to go into greater detail about those findings. During that second presentation, we're going to share our categories that were emerged, along with examples of the data that went along with those categories. So with that, I'm pleased to start with introductions. I am Omah Williams-Duncan, assistant professor at the University of Houston Clear Lake. I'm joined by my team of researchers, and they're going to share their information now.
Hi, everybody. I'm Sandy Watson. I'm an associate professor at the University of Louisiana at Monroe.
And I'm Ashley Smith. I'm a doctoral student at the University of Houston Clear Lake.
And I'm Yasmin Al-Rashidi. I'm a graduate assistant at the University of Houston Clear Lake.
So this phase 3 research project actually consists of the following partners: the University of Louisiana at Monroe, the Lunar and Planetary Institute in Houston, and the University of Houston Clear Lake. The exploration of the moon and asteroids by secondary students, known as EXMASS, is a NASA-funded education program that began in 2014 and provides 10 teams of approximately 5 students each from schools across the U.S. the opportunity to conduct authentic, student-led, open inquiry research with assistance from their teacher and a scientist over an entire year. The program is managed by the Lunar and Planetary Institute, is funded by NASA's Solar System Exploration Research Virtual Institute, also one of the same institutes funding this conference today. The article that you see on the slide here arose from previous research from phase 2 and involved Andy Shaner of the Lunar and Planetary Institute, myself, Maya Bakerman, and Sandlin Buxner, both of the Planetary Science Institute in Tucson, Arizona.
Phase 1 of the EXMASS research study was mainly quantitative. Researchers focused on validating the EXMASS surveys. In phase 3, we are applying an exploratory mixed methods approach to identify scientist, student, and teacher relationship characteristics. This means we are determining answers to our research questions by considering qualitative data found in emails and in open-ended response sections of the surveys, along with considering the quantitative data found from Likert scale components of surveys. The qualitative data is subjective and adds rich context and background to our study. Without these emails, the voice of the student or scientist participants would be lost. Qualitative data analysis requires us to determine categories of ideas. We refer to singular ideas within categories as units and the iterative process of categorizing ideas found within text as coding. So when we say codes or coding, we don't mean computer coding or programming. In qualitative research, we read participant statements, or in this case, emails between the scientists, students, and teachers to iteratively group statements within categories. We also agree upon the definitions of the categories, which eventually become, in our case, examples of relationship characteristics that could be emulated or replicated when attempting to duplicate EXMASS successes. There is little research highlighting mentoring or advising relationships between scientists and secondary students. Such relationships have the power of influencing the STEM pipeline, as students can learn directly from scientists. While initial research sought to determine validity of the EXMASS participant survey, phase 3 research seeks to define relationship characteristics between the EXMASS triads, that is, the scientists, students, and teachers, and generate new knowledge about such science inquiry relationships.
Our study focuses on 4 research questions. We have posted the most salient questions linked with our currently collected data. Additionally, for the purposes of this short talk, we are highlighting the research question that is aligned with our currently analyzed data and its most aligned sub-question. We want to remind you that data analysis is still occurring, so today's talk mainly focuses on the highlighted questions. How did the scientists interact with their student teams while facilitating authentic science inquiry? And what were common advising characteristics or elements between EXMASS scientist advisors and their student teams?
Currently, our research consists of 3 sources of data: EXMASS applications, emails, and pre-post surveys. For the purposes of this talk, we are only focusing on data from the emails. As of the date of this presentation, the researchers have collected and collated emails between 7 teams of scientists, students, and teachers. Within the last few weeks, we coded the emails. And again, we don't mean computer coding. In qualitative research, coding is the process of determining those categories by reading, comparing, and sorting text based on their content. So in this case, we read all the emails and grouped similar ideas to generate categories. After working individually, we met to discuss our categories. We normed and defined the categories. We determined that multiple occurrences of similar ideas appearing in a single email should only be counted once. We discussed and compared text within categories. We also agreed that 3 or more occurrences of similar ideas per category and per researcher constituted a category. These practices allowed us to establish what's known as intercoder reliability. Further, after this talk, we will retest our agreed upon categories to ensure we have solid agreement. Given the amount of data we have and the required analysis practices we must employ, our research again is ongoing. The applications and surveys will undergo quantitative and qualitative analysis, where descriptive statistics will be used for the numerical portions of the applications, and surveys and constant comparison analysis will be used for any open-ended response questions. This slide displays the participating teams that completed the 2021 EXMASS programs. While 10 teams started, only 7 finished and presented their research. As you can see, teams represented a variety of states and cities across North America. Each team consisted of 1 to 2 teacher mentors and 3 to 6 student researchers that were in their 2nd to 4th year of high school. Each team was assigned a scientist advisor. Now that you know who we are, how we analyze the data, and who generated the data, let's learn what these scientist, teacher, and student teams discussed in their emails.
So as we stated, our research is ongoing. We have begun the process of open coding the email exchanges between the scientist and the student teams. We have defined 2 main themes with multiple subcategories within those themes. In our next presentation, we will begin to define the 2 major themes, and we'll explain and provide examples of emails that fit within a sampling of the subcategories.
So at this time, our first presentation, which overviews our phase 3 research, has concluded. If you have any questions, I think it looks like we have a little time to answer any questions.
Definitely, and there is one in the chat that I'm going to read out really quickly. And I think this is something that a lot of people who do this kind of research really resonate with. So I have come across a bias held by scientists. When I try to share qualitative data, they do not think it is real or good enough. What strategies might be used to underscore the rigor of qualitative data? Your methodology is solid and robust, yet I know some scientists will balk because datum could be an idea, not a number.
So I think that that's where the intercoder reliability comes into play. There is a point where you can start to attribute some quantitative numbers or quantitative data to the qualitative process. And again, that's where the intercoder process comes into play. So I think you have to spend some time explaining that portion of the data analysis. I would love for Dr. Watson to maybe share her thoughts as well.
Yes, I agree. It's not as simple as it appears. So for example, in this study, we are about on our 6th iteration of analyzing the emails and identifying themes. And towards the end of that, we get together and we look at each other's classification and we try to come to agreement. And that's where we calculate our intercoder reliability. So at first glance, it might not seem scientific, but it is actually very scientific and takes quite a lot of time to achieve.